Dear friends, in today's lecture, we will discuss how to build the basic machine learning model using TensorFlow. Our today agenda is introduction of the supervised learning and linear regression with TensorFlow and how we will deploy logistic regression with TensorFlow and what is gradient descent and optimization. And after that, we will conclude our lecture. So first of all, we should know about the supervised learning. Supervised learning involves learning a function that maps input to the outputs. And you already know that in supervised learning, we use label data. We use the data which input and output is already known to us. Using the label data, we train our model. After that, we do some testing on our data. After that, we do some validation on our data. After that, we will do some accuracy check, performance check, and loss calculation, error calculation. Okay, so there are some types of supervised learning like regression and classification. In regression, we predict the continuous value, like finding the price of house, predicting the price of house, and in classification, we predict the categorical value, like it's a cat image or it's a dog image. So for classification purpose, we also use supervised learning, and for regression purpose also we use supervised learning. So this is some basic things about the supervised learning. Now we will know that how we will deploy linear regression with TensorFlow. So linear regression assume a linear relationship between input variable and output variable. So for that purpose, let's suppose the equation of a straight line, and that equation is given by y equal to mx plus b, where m is the slope and b is the bias or b is the intercept as well. So what is our goal? Our goal is to minimize the difference between predicted value and the actual value. Okay, so we have already discussed about linear regression. In linear regression, we have to predict a decision line. Using that line, we predict the output of our model. Now we will do some hands-on related to linear regression model using TensorFlow. And first of all, we will define our input data, variables, and the model. And our linear model will be a straight line that will be y equal to mx plus b. Here y is dependent variable and x is independent variable. Y is label data and x is input data. We will use gradient descendant to optimize the model parameters. We will use gradient descent to optimize the model parameter. Now, how we will deploy logistic regression with TensorFlow? So, logistic regression is used for which purpose? Logistic regression is used for classification purpose. This is the only regression phenomena which is used for classification. Logistic regression predicts the probability of a binary outcome. Its equation is y cap is equal to 1 upon 1 plus e to the power minus y, and y is equal to mx plus b. So it's a logistic regression formula. Here is exponential function, and we can also represent is y equal to 1 upon 1 plus e to the power minus z. It is a continuous function, and since it's predict the binary outcome, so our cost function will be used as binary cross entropy loss. To predict the loss, we will use binary cross entropy loss. And if we will use a regression, then there we will use mean square error, mean absolute error, or Huber loss as per the requirement. Now, for the hands-on purpose, we will define the input data, variables, and the model. We will apply sigmoid function while defining our logistic model. We will use gradient descent to optimize the parameter for binary classification. After this lecture, we will do some hands-on with Python coding. And in terms of gradient descent and optimization, gradient descent updates model parameter by computing gradient of the loss function. Gradient descent update model parameters by computing the gradient of loss function. And learning rate control the size of steps taken during optimization. So gradient descent and learning rate are very important in terms of deep learning. Experiment with different learning rates to observe model performance. So by adjusting our learning rate, we will calculate the performance of our model. So other example, we can say polynomial regression. We can also implement polynomial regression using TensorFlow. We can train a multi-class classification model using softmax on iris dataset. Where we need a multi-class classification, there we apply softmax function. We also apply the different optimizers like Adam and RMS prop. In conclusion, we will know how to implement the basic model like linear regression and logistic regression in TensorFlow. We will apply gradient descendant and optimization algorithm for minimizing the loss, and also we will do how to implement the TensorFlow in regression and classification tasks. This is all for today lecture. See you soon in the next lecture with implementation of linear regression, logistic regression, optimization, and